So, how are the exercises going, guys? Where are you at? Are you almost done with the problem set? Any challenging problems there that seem a bit out of reach? Anything that we should discuss in class? If you're done with the problem set, just say so. Just tell me you're done. If not, just say approximately where you're at, which exercise. Anyone? And Michelle, I think you probably know something about it. Okay, several of you are done. Okay, so some of you are about the middle of the problem set. And okay, we'll see at the end of the class if we have time to go through any exercises that you might be stuck on. But since we have to be done by strictly 10:55 today, I can see several of you got stuck. Okay, we'll figure out how to sort that out later. Let's just move straight on to today's topic, I think, which is now that we've covered the object store, we've covered trees, we've covered blobs, we've mentioned non-lightweight tags, annotated tags, but we haven't seen them and we won't. We'll just mention them. We've seen commits. That's the last lecture. And today we're going to talk about branches. So let me see if I can bring up the slides. Branches. Hopefully you've been able to find the slides in your browser as well. The URL is, as you know, Umuzi.GitLab.io/git slides. So, now that we know that commits are actual objects in the object store, what are branches? And this is the easiest way of describing them. Branches are simply labels that you attach to commits. That's all a branch is. A branch is just a sticker that you put on top of your commit. Nothing else. If you've had a different model of what a branch is, it's time to re-evaluate your mental model. Because inside your head, what a branch should look like is, and we'll draw diagrams of this later in this class, it's just a sticker. It's just a label. Now, inside of Git, a branch is actually, it consists of two parts. It consists of a name, and it consists of a hash of the commit that the branch points to. And that's it. That's it. And the commit that the branch itself points to in Git parlance is called the head of that branch. So a branch points to a commit, it names a commit, namely the commit it's attached to, and that commit is called the head of the branch. So if we look at Git Commit Graph, I've shown you graphs like this earlier on, and you should hopefully they should make sense to you. At least you should understand that the nodes here are commits, and we've talked about how commits have parents. The way this diagram is supposed to be understood is the parents are to the left. So the very leftmost commit in this diagram, which is a white node, that's the first commit that was ever made to this repository. And then the next one was made right after, there's one that was made right afterwards with the first commit as its parent. And then you can see it sort of branches off into a blue commit and a green commit. And both those commits have the second commit as their parent. And we've sort of branched off into two different directions here. There are 3 commits that are colored green here. The second green one is the child of the first green one, and the third green one the child of the second one, which means that someone at some point checked out the green commit, made some changes, made a new commit, and it got the first green commit as its parent. You can see here the branches are indicated with 2 square labels here. You have a master branch, which is just a label that points to the rightmost blue commit. You have a feature branch, which is just a pointer to the outermost branch. And the way things work, I will try and bring up a diagram here. Let me see. So hopefully now you have a screen with a diagram on the left side and a terminal on the right. And for now, you can just disregard the terminal. And we're going to show you how branches and commits interact. So at the after you've initialized your repository and you've made your first commit, your repository looks like this. You have 1 commit in the object database, and you have 1 branch which points to that commit, and that branch is usually called master. Now, all a branch does is to say, you know, if you check me out, this is the commit that you'll check out into your working directory. And if you want to continue the work that is on this branch, this is the work that you'll use as a basis for that. So if you check out the master branch, it will be already checked out unless you've made any other branches. If you have the master branch checked out and that first commit is checked out, if you then make changes and create a new commit, the following process will happen. First, you're going to you're going to create a new commit, you're going to do some work, you're going to stage it, and you're going to create a commit. And the commit goes into the object store, and it'll have A as a parent, right? And if you committed this to the master branch, what will then happen is the label moves. And suddenly your commit becomes the head of the master branch. Now, what happens, by the way, can you see this diagram? Is it clear to you? Is the font size big enough that you can read what's on your screen? It's pretty vital that you can see what I'm doing here. This is not an ideal way of doing diagrams on the fly, but since we don't have a whiteboard, this is what I have to do. Hopefully you can see it. Okay, well, what happens if you check out another branch? Say your repository looks like this. You made some changes, you created a new commit, your master branch is here. Let's say now you're creating another branch. What happens? Well, what happens is the following. You get another label that points to the exact same commit. Let's call this feature, or just feat. So, if you check out feat, what happens is that commit B is the one that will be checked into your working directory. The tree that is saved with that commit will be checked out. All the blobs there will populate your directory as files. And the selected branch will then change to feat. If you now create another commit, let's say you make some more changes. At this point, you're on branch feat, you've checked out feat. If you make some more changes, you create a new commit, what will happen is the following. We get another commit. B becomes its parent. And feat moves. And that is what your repository looks like. all it does is to say that, you know, there's some work has happened here. We started out at A, moved on to B, then I created another, then my work took a certain direction. I wanted to change the work in a certain way, indicated by the feature branch. And you commit, when you change your work in the way that you want, and you commit, you get a new commit that points back to the work it was derived from, and you get the label that says, you know, this is the last commit on this line of development. Now say you check out master again. If you check out master again, what happens? Well, then B suddenly, then B will be checked out into your working directory. All the files that are attached to the B commit will be checked out into your working directory, right? So all the work that was on your feature branch in commit C, that is of course still in the database, but all your files will now be the files that are associated with the B commit. Now let's say you make some changes and you of course update the index and you commit. What happens? You get another commit which will have B as its parent, and master moves up here. And that's what your commit graph will look like. So this is how branches work and how they interact with commits. Does that make sense to you? Is this the model you've had in your head when you've been working with branches in Git before? Have you thought of them as labels that are just attached to commits? I think probably not. Many people will think of branches as something along the line of a directory or a linear log or something. This is how you should think of branches. So let's go back to the slides. Right. Often we use the term to be on a branch. We ask, is a commit on a branch? Well, to be on a branch means that the commit is either the head of a branch or it's the ancestor of the head of the branch. So if we go back to the repository we just discussed, the hypothetical one that we created a diagram of, what does it mean to be on the feature branch? Well, right now C is the head of the feature branch, so C is on the feature branch. But also C derived from B. B is an ancestor of C, so B is also on the feature branch. And since A is an ancestor of B, hence an ancestor of C, A is on the feature branch. Those are all the commits that are reachable from C, which is where the feature branch is pointing right now. A, B, and C are on the feature branch. What about the master branch? Which commits are on the master branch? Well, D is on the master branch, clearly because D is the head of the master branch. Then B is an ancestor of D, so B is on the master branch, and A is on the master branch. So B is actually on two different branches. It's both on feature and master, so is A. C is currently just on the feature branch, and D can only be found on the master branch. Does that make sense? Any questions? Right, so what's the purpose of a branch then? Well, what a branch does is basically to say that I have a purpose, and that purpose is indicated by my name. We'll talk about what that purpose can be later on, but it has a purpose. It's there in order to remind you that if you want to continue this work, for example, you want to create a new feature in your program, you want to add another set of things that your user can do in your app. You want to add a chat to your web app. That could be a feature that you want to add. And what the branch is saying, my name is chat, feature chat. And if you want to continue the work of implementing the chat, this is the commit you should check out. And when you add a commit, I will make sure to follow along to indicate to the next person who is going to commit to this branch where he should continue the work. That's why this label system works the way it does. It's there to indicate where you should go in order to continue this work. Then, as we've seen, when you commit on a branch, the previous head becomes your parent, right? You checked out the head of the branch, you commit again, and the commit that you created will have the previous head of that branch as its parent. And your commit then becomes the new head of that branch. Now, as I've told you, branches in Git are not objects. They don't go into the object store. They're just pointers. They're just labels that exist outside of the object store. And there are actually several places in Git where commits are referenced in ways similar to commits. For example, there's the concept of a tag, a lightweight tag. Not the kind of tag that's used as an object, but the kind of tag that isn't. I'm not sure if you've seen these. They're by far the most common kind of tag. And they're basically just used as post-it notes that you just stick onto a commit in order to remind you about something. For example, you could use a tag to indicate which commit was shipped to a customer, as in which commit was built and shipped off. You could use it to indicate version numbers, like this commit, this is when we froze the code base, and this is version 1.2, for example. That's a common use of tags. Now, both tags and branches, they're just an instance of what in Git is called a ref, or a reference, but people just call them refs. And if you look inside the .git directory, you will find that all refs that includes branches and tags. They're found inside the refs directory. And we're going to have a look at that together. Now, there's, of course, a concept of checking out a branch. And as we've said already, when you check out a branch, your working directory will be populated with the files that were checked in with that commit. So Git looks at the commit, it says, oh yeah, this commit has a tree, that tree represents the working directory. And inside the tree it will find a lot of blobs, and Git will say, hey, yeah, this blob XYZ should be checked out with file name so-and-so. And the next blob XYZ will be checked out as file name so-and-so, etc. That's how it goes. That's the first thing that happens. Then Git will update a pointer called head, and that's capital HEAD. So head is, of course, the head, which would the head of the branch that you checked out, as in it's the commit that the branch you checked out to points to. So head in Git parlance, head with capital letters, it's the head of the checked out branch. It's the most recent commit on the branch that you have checked out. It's a bit confusing that they choose to just call it by a name that is already in use, and the only difference is the way it's capitalized. But that's the way it works in the Git world. So head is also located inside .git, and you'll find references to head when you run into problems inside Git very often. And one of the things that might happen to you, and probably has happened to you if you've used Git, is that you might at some point end up in a detached head state. Has any of you seen that message before? Git tells you that something can or cannot be done because you're in a detached head state. If any of you have seen that message before, just say, yes, I've seen this, or no, I haven't. It happens under several circumstances that we'll see later on. Okay, you have it. This is what happens if you check out the commit directly, right? We've talked about checking out branches, which means that you take a commit, you populate the working directory with the files inside that commit, and then head gets changed to the branch that you've checked out. But Git will also allow you to check out the commit directly, which means that it'll take the files that were checked out, and it will take the files that were checked in with the commit. You'll get those inside your working directory, but you're not on a branch anymore. So head has nowhere to go. You can't set the head pointer because you didn't check out a branch, you checked out the commit directly. And that's how you end up in a detached head state. Now, sometimes when you run Git commands, you'll see people use the @ sign to indicate what commit that you should apply that command to. The @ sign is a common alias for head. So very often when you see @ it refers to head, i.e. the branch that you have checked out. Now, we've also talked about garbage collection. We talked about how Git will try and pack blobs together, pack trees together, and pack commits by using change sets. Well, garbage collection does more than that. Garbage collection will also prune away blobs and the commits and trees that are not on any branch. Because if they're not on a branch, Git will just think that, they've removed the labels that led us to these commits, therefore you're probably not interested in them. However, it takes some time. Git doesn't garbage collect blobs, commits, or trees until they're at least a couple of weeks old by default. So if you accidentally delete a branch, you shouldn't worry. All the commits still exist inside the database, but if you wait too long, Git might actually decide to discard of all of them and delete all those commits and blobs that were saved. How do we manipulate branches? This is probably something you know already. If you run git branch with a name, it'll create a new branch. In order to check out the branch, you use git checkout and the name of the branch you want to check out. It's also possible to combine these two, as in to both create a branch and check it out at the same time. Because if you just run git branch and the name of that branch, Git will create the branch, but it won't check it out. So your head will still be the previous branch that you had. With git checkout -b, on the other hand, you'll get a new branch and it'll be checked out. So head, capital head, will change. And if you ever need to delete the branch, and that'll happen certainly, use git branch -d. These are probably commands that you've seen already, at least most of them. And what if you need to move a branch? Because remember, I've told you that a branch is just a pointer to a commit. Going back to the diagram. You might be in a situation where you'd want to actually move a branch completely, move the label, let's say master, over here to C, like that. Or a very common situation you're in is actually that, you created a commit, but you're not happy about the work, so you want to backtrack. So basically you just want to move master back to where it came from, say B, in this case, or even all the way back to A. Very common situation to be in. And you should know how to do that. That is done using git reset. And the reason it's called reset is basically because the most common use case is you want to reset your work. You want to backtrack to where it was because for some reason you're not happy with the latest commit or commits. So you're resetting the branch. And the command that you should know about is git reset and then the commit. And by commit, I of course usually mean commit hash. So as a stand-in for commit in angular brackets there, you should put the commit hash that you want to return to. Or you can refer to the commit by branch name. So if you have a branch pointer that points to the commit you want to reset the branch to, you can use git reset and then the branch name. If we go back to the diagram, if you run git reset B, let's say B is the hash of B, a hash of this commit, then this would happen. Now if you ran git reset feet, the name of this branch, which points to C, master would move here. So you can refer to the commits by their hashes or by the name of branches that point to them. Hopefully that makes sense. Then, of course, if you just reset a branch, all that will happen in Git is that the branch pointer moves, nothing else. If you run git reset commit, nothing will happen inside your working directory. If you want to reset your branch and check out the commit that you're resetting to, you can use git reset -- hard. You can do a hard reset. And what will happen is that if you do a hard reset from D to B, the first thing that will happen is that master moves. Second thing that happens is that B will be checked out into your working directory. If you don't do a hard reset, B will not be changed. B will not be checked out into your working directory. So there's two different reasons why you might do. Well, there's a reason why you might do one and not the other. So say that what happened in D was just beyond what can be rescued. It was such horrible work that you want to discard it and never see it again. Then you just do a hard reset. You hard reset to B. B is checked out. The work that was done on B is essentially just discarded because you're checking out the files that reside inside B. However, if you're in the situation where, I created this D commit, but I wasn't done. I shouldn't have created that commit yet. I should do some more work or change my work a little bit. Well, what you can do is to just reset master. Your working directory will be exactly the same as it was. You can then make some changes, commit them, get a new commit, and move master there instead. So that's a common use case. Now, what happens if you accidentally delete a branch? You maybe, even worse, you check out another branch and delete the old one. And the old one, of course, had work that you don't want to lose. Well, in that case, don't panic, because garbage collection doesn't happen for a couple of weeks anyway. So as long as you can recover the name of the last commit, the name of the previous head on the branch you deleted, you're fine. You're not going to lose work. So relax, sit down, dry the sweat off your forehead, and this is going to be perfectly okay. Happens all the time. And if you don't remember the name of the head, if you don't remember the commit, that is, the commit hash, then what you can do is to run git reflog. Git reflog is a log of all the commits that you've had checked out into your working directory. So if you run git reflog, you should be able to locate the commit that was on that branch, and you can then check out the commit directly. As I said, As we said earlier, you can go into detached head state by checking that commit out directly, and then you create a branch there, and all is good. Then, what are branches used for? So because we've talked about branches, we've said what they are. They're basically labels and so on. You can put them on any branch you want. Well, that's well and good, but you know, branches ought to be used in a certain way. I mean, just knowing that you can use labels, use branches, doesn't say much about how they're supposed to be used. There are conventions, very strong conventions about what branches are supposed to be used for. And we basically split branches into two different types. You have long-lived branches and you have topic branches. And long-lived branches, they're branches that will never be deleted. They follow your project from its inception, from the start until its end. And there's at least one such branch in most projects, and it's usually called master. It's the first branch you create, and that branch will hold the stable production ready code. So whatever is on the master branch should be code that is ready to be shipped to your users or put into production. Sometimes you might have more than one long-lived branch. Sometimes you might have a develop branch, which will hold the latest development edition of your code. It should be semi-stable. It should be stable enough that what's there are features that are pretty much done. They're written, they're finished by the developers, but they haven't gone through QA, quality assurance, or they haven't been bug tested, or they haven't been tested by a focus group, or whatever you might want to do to that code before it's actually folded into the master branch, the production branch. Also, sometimes you might have a long-lived staging branch, which is where you put code that will be run in a staging environment, like a test environment, before you move it into your production environment. Then the other kind of branch type we have is topic branches. And topic branches are branches that you create for a certain purpose, and you delete them when that purpose is no longer needed. When you're done and you've folded that code into another permanent branch, these branches are supposed to be discarded. And there's usually about 3 different kinds of topic branches you might see. You might see a feature branch, which will hold the code that you're working on when you're working on a single part, a single component of your code, a single feature, a single something that your code might do to the end user, a chat application or messenger interface or file storage or some discrete feature of your code that you're working on. And that's the only thing you're working on in that branch. And when you're done, you will usually merge your feature branch into another branch, and will a permanent branch in that case. And we'll look at what merging is and what it does in the next lecture. And once that has been done, the feature branch is basically deleted. It's gone. It's served its purpose. Now you also often have fix branches, which is a branch created in order to fix a certain bug. And sometimes, especially if you're working on a system that resides online, like an online web service, for example, sometimes you've put code into production and then a bug is discovered. Then sometimes you might actually have to fix a bug directly on code on the master branch. You have to just quickly push out the fix so that your system is usable again. That's called a hot fix. A hot fix is basically a fix that is done directly to code in production. And you might want to create a hot fix branch and fold that straight into the master branch. Merge it into the master branch when you're done. So features and fixes and hot fixes, those are very common topic branches that you might see. And I really wanted us to go through an example of working with branches together, but if we're supposed to be done by 10:55, I think we should do that next Monday when we have a bit more time. But instead, I'll just discuss what this process that we just talked about looks like on paper. So let me bring up the diagram again. Maybe I can even, let me see if I can make it a bit bigger. Well, there, and let me move that out of the way until we need it. Okay, so let me just delete all of this. This process that we talked about, where we have topic branches and we have long-lived branches. What does it look like in real life, on paper? What does the graph look like and how does it change? Well, you start out with a single commit, which contains the bare bones of your application. It's where you start from. Everyone needs to start somewhere. First commit goes in on the master branch. Then you need to start developing your application. You create a feature branch. For example, let's say you're creating a chat application. You need some way of creating users. So you create a feature branch in order to set up a user database, a way for users to log in, etc. You might call that branch feat/user. Then, of course, when you create it, the label just goes straight on the commit you're already at. But then you start doing the work. You start creating classes and functions and methods and database files, database schemas that will allow you to implement this feature. And your repository will look something like this. Whoops. Yeah. Let's say you have 2 commits on the feature branch. Okay, let's say your work now is done. What do you do? Well, at this point, you're supposed to move your code into the branch that contains code that's ready to use. And there's 2 ways of doing that. One is just saying, B2, that's the end of development for the user feature, so we'll just move the master branch up here. That's one way of doing it, and some companies do it this way. Another way of doing it is by doing an explicit merge, which will take the code in the feature, which will take the code in B2 and merge it with the code that already exists in A. And this is what the graph will look like. We now have C as a merge commit. What has happened is we merged the feature branch with the master branch. This is we'll look a bit more at this process in greater detail tomorrow. But, oh, I'm sorry, that arrow goes the wrong way around. That's what it'll look like. And as you create more feature branches, you might create yet another feature. Like this. That might be your actual chat application. And when you're done, you'll merge feature into master. You'll get another merge commit. With D1 and C as its parent, and master moves again. And now, of course, if you remember what we talked about, feature branches should be long-lived. So when you've merged them, you should usually delete them. And your graph will look something like this. This is actually a very ugly way of laying out this graph. Let me see if I can lay it out in a way that looks a bit more reasonable. Whoops. Of course, making things look reasonable is really important here. Okay, something like this is what the situation will then look like. And we'll go through the process of creating a repository, creating feature branches, and merging things in our next class. But at least now we've seen everything from a top-down point of view. I hope things at least make some sense to you at this point. What I really wanted to do today is to just give you this mental model of what a branch is and how it works in relation to commits. So, are there any questions at this point? Anything that's a bit unclear? Anything about the purpose of branches that seems unclear? Anything at all? No questions. Everything was perfectly clear first time round. I know getting the right picture, the right mental model for things like this, that takes some time sometimes. And the Git model of doing things is different from a lot of other version control systems. Subversion, for example, SVN, has a very different model for what a branch is. This is not the kind of model that's used inside SVN. So what's called a branch in SVN is a different thing altogether, which is the reason for why I want to really show you the Git way of doing things and make you understand the way Git models things. So some of you have been using topic branches in a product that you're working on, and that's very good. You should always make sure to use topic branches to separate your work. It makes it much easier to split your code into parts that are in essence so different. You should think of them as different things and make it possible to work with those different components as separate components. You always want an application to be modular. You don't want it to be one big tangle of everything. You want things to plug into each other, and when you're working with topic branches, you're sort of forced to think that way. I'm now working on a discrete feature that it has its own life cycle from other components inside the system. And some of you are saying that it makes sense, but it's too much to grasp at one go. And I can definitely understand that. It's a lot to grasp. So next class, we're going to go through a practical example of working with branches, and we'll see how everything fits together inside Git. And at that point, you'll get another problem set, which will be about commits and branches. So I guess that's it for today. Thank you very much. I've thrown a lot of abstract material at you today. I'm sorry for that. But hopefully you just, try and look through the slides, think a bit about what we talked about today, keep it on the mental back burner, and we'll see more practical examples next time. So I guess that's it for today. unless there are any more questions. I think it's 10:51, so it looks like you'll have time for the meeting. Not keeping you longer than we should today. So yeah, great. All right, have a great meeting wherever you're going, and I'll see you again next Monday. Thank you very much, guys. Yeah, have a good day.